Good morning, everyone. Welcome back. Day 2 of week 9. Today is May 24th, 2022. And today we're going to continue reviewing. What are we going to review today? We're going to review 2 topics. We already reviewed 3 topics last day. We reviewed addition of polynomials, subtraction of polynomials, which is one single topic. The introduction to polynomials, by the way, which is the name of the polynomials according to the number of terms and to its degree, and GCF, factoring using GCF. Okay, so 2 topics already. Today we're going to practice multiplying a polynomial by a monomial and multiplying binomials using FOIL. Okay, so when we are multiplying a monomial to a polynomial, we are going to be using the distributive property. We will be multiplying coefficient with coefficient and variable with variable. If we have the same variables, remember, we add the exponents, okay? If we don't have a variable, then we just multiply the coefficients and we copy the variable. If we have different variables, then we just copy them both with whatever exponent they have. It doesn't matter if we have the monomial up front, like in this exercise, or at the very end of the exercise, like in this part. We're still going to be using the distributive property, and we're still going to multiply the monomial times every single term inside the parentheses, okay? Same thing goes with the second exercise, except that we're going to begin all the way to the left, okay? So let's continue with this one first, and then we're going to solve the other one. Remember, monomial times monomial, we multiply coefficient with coefficient and variable with variable. If they're the same variable, we add the exponents. So how much is 2x times x?
2x to the square.
2x to the square. Why? Because we have an invisible one over here. So 2 times the invisible one is 2. And x times x, we add the exponents, which they are invisible ones, and that will give us a 2. Now, 2x times 8.
16x. 16x.
Positive 16x. Because we multiply the coefficient with the constant, and we copy the variable. And that's it. That was distributive property. Easy peasy, right? Now, the second one, like I told you, we're going to multiply the monomial that's at the right times everything inside the parentheses, starting from the left one, the middle one, and then the last one, okay? It's exactly the same thing. So how much is n cubed times 2n?
2n to the fourth power.
Exactly, 2n to the 4th power. How much is 2n times n?
2n to the second power.
Positive 2n to the 2nd power. And how much is negative 5 times 2n?
Negative 10n.
Franco, do you agree? Okay, so that's it. We cannot do nothing else because they are not like terms. They have different exponents. Okay, remember, like terms are only those terms that have exactly the same variable with exactly the same exponent. So we finish in this part. Our answers should always be written in standard form. And what is a standard form? Writing it in alphabetical order and from the greatest exponent in descending way, meaning from the greatest all the way to the least, okay? So this is our final answer. Let's go with the next one. So in this other exercise, we have a monomial that will be multiplying a what? What is this inside? What is it called?
A trinomial.
A trinomial. Okay, just for you to know, this, just in case, is a letter B. Okay, so we got 8b to the square times negative b squared plus 7ab minus 7a squared. So we're going to do the distributive property and we're going to multiply. How much is 8b squared times negative b squared?
Negative 8b to the fourth power.
Very good. Negative 8b to the fourth power. Because we multiply the invisible one, negative times the 8. So that would be negative 8. And we add the exponents because they're the same variable. So that's b to the fourth power. Now 8b squared times 7ab.
Positive 56
Positive
AB to the third power.
to the third power.
Positive 56.
AB to the third power.
AB to the third power. Very good. Why do we copy the A? Because it's a different variable, so I cannot add the exponents. Now the very last one, 8b squared times negative 7a squared.
Negative 6 A to the second power, B to the second power.
Very good. A to the second power, B to the second power. And that is my final answer. They're different variables, so I cannot do nothing else. Even though I told you that standard form means that you need to rewrite it with the alphabetical order, in this case, we're going to keep the greatest exponent first, and that will be okay as well, okay? Okay, let's go with the next part. This is the multiplication of a binomial times a binomial. We are going to use the method that we are going to call FOIL. FOIL is basically the procedure that you need to do, which is multiply the first term of the first parenthesis times the outer term and the inner term of the second parenthesis, and then you do the same thing with the last parenthesis, okay? So in other words, it's really property, but by parts. So the first term of the first parenthesis will multiply everything inside the second parenthesis, and the last term of the first parenthesis will also multiply everything of the second parenthesis. Okay, so we're going to go part by part. Now, just remember, every single time that you have exactly the same exponents in your binomials, the middle terms are going to be like terms, okay? So let's see. Now we're multiplying a binomial times a binomial. How much is x times x?
X
to the second power.
X to the second power. How much is x times 8?
AX.
X.
So plus 8x. We finished with the first term. Now we go with the second term. 3 times x.
Plus 3x.
So
3x.
plus 3x. And 3 times 8
Plus 24.
plus 24. Okay, just to make it right, this is a parenthesis, okay? I know you didn't get confused, but just in case. Now, I told you, middle terms are like terms, and you can see 8x is a like term of 3x. So we're going to simplify that in order to have the answer in the simplest form. I copy the x squared because it does not have no like term. How much is 8x plus 3?
Plus 11x.
11x.
Positive 11x. And I copy the 24 because it does not have a like term either. And that's it. That's my final answer. Questions? No? Okay. We have a chat in here. Okay, Dennis. So now we're going to multiply, just like we did in here, the first term times everything inside the second parenthesis, then the second term, which is a 1, times everything inside the second parenthesis. Let's go ahead and solve it. In this case, both variables have a coefficient. Will it change my procedure? Of course not. How much is 2p times 6p?
12p.
12p to the second power.
12p to the second power. How much is 2p times 4?
Plus 8p.
8p.
Plus 8p. Now we're going to multiply the second term. How much is 1 times 6p?
Plus 6p.
So plus 6p. And how much is 1 times 4?
Plus 4.
Plus 4.
Plus 4. Do I have the middle terms as a like term? Are my two middle terms like terms?
8p and 6p.
Yes. And we simplify, okay? So 12p squared How much is 8p plus 6p?
Plus 14p.
So plus 14p. And plus 4. And that's it. Okay? Easy peasy. Now, before simplifying anything, we got 4y squared plus 2 times 3y minus 1. Are my middle terms going to be like terms?
Yes.
Okay. Are you sure? Are they going to be like terms ones that we multiply, just like in this case? Yes or no? Like in this case.
Yes.
Okay. They are not. Why not? Because they have different exponents. And I just told you, if the variable have different exponents, the middle terms are not going to be like terms. And let's prove it. Okay, let's see if I'm right. So 4y squared times 3y.
Y to the third power.
12y to the third power. Very good. 4y squared times negative 1.
Negative 4y.
Negative 4y to the second power.
Very good. Now the second term. 2 times 3y.
Plus 6y.
Positive 6y.
Positive 6y. And 2 times negative 1?
Negative 2.
Negative 2.
Negative 2. So again, are the middle terms like terms?
No.
No.
All right. So you see, if they don't have the same exponents, they are not like terms. Okay? They are not like terms. This is my final answer. Any other question? Do we understand the topic?
Yes.
Okay, exercises similar to this are common in the exam. So this is day 2 of review. And next class, we're going to review special cases.